Let's try again. What is a characteristic? For anything. It doesn't have to be for a function. What's a characteristic? Yeah, like your feature. So characteristic of let's say a football player. What's a characteristic of a football player? Strong. What else? What did you say? Legs. Are we good? Okay. They're athletic. Usually, do we see small, little football players? Sometimes, right? Usually, if it's a small football player, they're probably what? Really fast. Yeah, and they're fast, right? Usually, a big guy isn't usually the super fast one. Sometimes, but not usually, right? All right, so characteristics of an exponential function. We're not going to be talking, obviously, we're talking about what it looks like, right? What it looks like, what it's doing, all of those fun things. So, we have 3 functions we learned about this year. Linear functions, absolute value functions, exponential functions. Okay? So we're on the 3rd one. All right. It's a little bit trickier than the than the absolute value. So characteristics of exponential functions. So our essential question is, what are the characteristics? Probably on purpose. All right, let's talk about what the function actually looks like. What's the function equation? So an exponential function is in the form of f of x equals b to the x plus k. B to the x plus k. In IM2, we added an h. For now, there is no h. You will not deal with h in IM1, okay? It's just b to the x plus k. Question. What do you think k is? Your vertical shift. Where do we do that? Yes, you're an absolute value, right? K is still the same thing. It's still a vertical shift, but it also means something else. It also is an asymptote. It's called an asymptote. An asymptote is the line that can't be crossed. The function approaches it but doesn't touch it. So it's kind of hard to see sometimes. It looks like our graph is actually touching it, but it's really not, okay? We're getting really, really close to it. Does that make sense? So if we're talking like 0 as our asymptote, we can't cross 0. We get really, really close because we can have 0.00004, right? It's not 0. It's close, but it's not 0. Or we could have 0.0001. Do you understand? So it just means that we're getting really, really close. It looks like we're going to touch it. Almost looks like it is touching, but it's really not, okay? Now, you have 2 types of exponential functions. You have what we call growth. Growth happens is when b is greater than 1. B stands for a number, by the way. So b is a number. If you notice, your variable is located in the exponent, right? So your variable is in the exponent, which is why you have an exponential graph. Do you understand? So your variable is in the exponent. This is why it's exponential. Exponent, exponent. Okay? So variable is in the exponent, which makes it exponential. So growth means b is greater than 1. b is a number. Oops. b is a number, okay? If b is greater than 1, you have growth. The reason why it's growth is the exponential graph grows really fast. So like something like that, right? It starts out super, super slow, and then it jumps. So that's your growth, okay? It's going super, super slow, and then it jumps really, really fast. My email is going off over there. Okay. We good? Now the other one we have is called decay. Decay is when your b is located between 0 and 1. So it's a fraction, but remember it's a certain kind of fraction. It can't be where your numerator is larger than your denominator, because then that just means you're bigger than 1, right? So it has to be where your numerator is smaller than the denominator. So like 1/2, 2/3, 3/4. Any of those, that means you have decay. Decay is when your exponential graph decreases fast. Bless you. All right, when you're ready, go ahead and cut out number 1 with the directions. Do you want the directions? All right, as you're going it in, I'm going to read to you what it says. It says, for each exponential function, identify the following, whether it's growth or decay, whether you're increasing or decreasing, the asymptote, x-intercept, and the y-intercept. I forgot to mention increase, decrease, but it's easier to look at it when we're graphing it. Okay? All right, ready? So what we're going to do first, letter A, we're going to need to decide, is it growth or decay? So is this growth or decay? Why is it decay? Because it's going down. So it is decay. Okay, letter B wants to know, is it increasing or decreasing? Well, if it's going down, then it's what? It's decreasing. We always read left to right. Now we need to know, where is it decreasing from? So remember our domain. Remember that domain thing? Let's talk about domain really quick. As your x's, so watch, as my graph is going this way, is it ever stopping? No, it's still going this way. Does that mean your x's are still going also? Yeah, so our domain is from where? What do you think domain is? What's our domain? Negative infinity to positive infinity, because it's the x values, right? This keeps going, and it keeps going this way, and it doesn't really stop, right? So our x values are negative infinity to positive infinity. Our range isn't the same, but that's okay. Our domain is the same. Make sense? Kind of like absolute value, your domain was negative infinity to positive infinity, but your range was based on where it was at. Same thing is happening here. So it's saying it's decreasing, but where is it decreasing from? Isn't the whole thing decreasing? Isn't the whole thing decreasing? Yeah, so it's decreasing from, guess where? Negative infinity to positive infinity. It's all your x values. Isn't that my domain? Yeah. Okay. Letter C wants to know, what is the asymptote? We always say k equals. K equals. Now what I want you to do is I want you to look at the graph. Do you see how the function comes really, really close to this line? Is it really touching this line? It's really not. So it looks like it is, or we're going to pretend it is. It looks super, super close, right? But it's not touching it. It's getting super, super close to it. So the asymptote is this number right here. What number is that? No, it's not 0. It's 1. This is x. So 1 up is just 1, right? So your k is equal to 1. What? There is no h. In IM2, there's an h. For now, there's no h. Okay, do we understand? I'll show you. It would be there. Bless you. I know it would look different. Say that to the IM2 kids. They beg to differ. Okay, ready? So K is 1. Got it? Make sense? Easy. All right, now let's do the next one. Next one says to do, what is it? X-intercept. Is it touching the x-axis? No. Is it ever going to touch the x-axis? Why? It's going to come close to, not to the x, to what number? To 1. Is it ever going to pass 1? No. So is there an x-intercept? No. So you can just say none. Can there be an x-intercept? Yeah. Is there always an x-intercept? No. Well, you should put your phone away. Letter E. Y-intercept. I want you to find the y-intercept. Mark it on the graph. What does it mean to be a y-intercept? On the y-axis. So it's not B on this one. Because B is a number. It's different. It's not B on this one. It's only when you have a line. It's right here. Is it a pretty number or not really? Not really. So we're going to give it a number. We're going to say it's, what is what in y-intercept always start with? What number?
0.
So 0, very good, comma 0.4, 1.4. You like that number? I wouldn't say it's quite in the middle, so I wouldn't say 0.5, but I could be 0.5, 1.4, 1.2, right? Something like that. If you said 2, would I mark you wrong? If you said 1, would I mark you wrong? Yeah, okay. So it'd be relatively close. We good? Questions on this? All right, you're going to do which one? You're going to do B. Let's go. Notice I like to highlight my asymptote, so if you want to highlight it, you can. If not, you need to color it in with a different color so you can see it. It's hard to see when you use a pencil or a black pen, so if you have a blue pen or a red pen or a purple pen or a highlighter. If you want a highlighter, get one. All right, growth or decay? Growth, because it's going what? It's going up. Increase or decrease? Increase. From where to where? From negative infinity to positive infinity. Very good. The whole thing is increasing. Letter C, your asymptote. So if I take my highlighter and I highlight it, now this is where some people got confused. Hard part to see is that we don't keep all of the x and y axis like on a line, right? We've cut it. You see how there's very little at the bottom? Kind of like here too. So what I like to do sometimes is mark the origin. The origin is located right here, correct? So you can call it O, that's the origin. Then you can count your points a little bit better. Do you understand? Because it's kind of hard to see. Or you can highlight the x-axis also, but highlight it a different color. Does that make sense? So if I count the origin, here's the origin. How many down is that? It's 1, so it is k is negative 1. Does that make sense? Okay. See how it's easy to highlight the origin? You can highlight your x and y axis one color and then highlight your asymptote a different color if that helps you. Because sometimes it is hard to see where it's at. All right, next is x-intercept. Is there an x-intercept this time? Yes, there is. Where is that x-intercept located? Negative 3, comma, 0. It's right there. Let's be careful when we write it, guys. Negative 3, comma, 0. Close. Make sure you write it in the right order. Letter E is y-intercept. Y-intercept is located on the 0, comma 7 is correct. It's right there. Anyone have it all right? Very good. How many of you had little mistakes, but you understand what you're doing, yeah? Questions? Okay, summary. If you, on the back? Yeah. You can write on the next page, or you can take an index card.